So this is a question from GCSE vector proofs. There are three types of vector proofs, and this one is about show that NMC is a straight line. Okay, so let's get started. APB is a straight line, it's given to us. N is a point on AP, it's already labeled. Vector AB is A, that's also labeled, and AN is 2B and NP is B, which is already labeled in there. Any vectors that's not labeled in the diagram, we would go on and annotate it. Okay, so part A states find the vector PB. These are like 1 marker starters that all of you are aiming for. Any level on the GCSE paper should be able to access that. Okay, so that goes from 5 to a 9, but anyone can access a question from here. So part A. So to find vector PB, we're going to go P to A, and then A to B. So P to A is going to be, we've traveled the opposite direction, that's going to be minus 3B, and then A to B is going to be plus A. Just keep an eye out on the direction of the vector that's given to us and the path that we are taking. So we went from P to A, so opposite direction, negative vector. So minus 3B plus A. So part A is done. That's 1 markers. Part B is a midpoint on AC. So B is a midpoint on AC, which means the length of AC is 2A. Okay. As you are reading these questions, use them as a bit of a checklist. Annotate the point on the diagram and then move on to the next point. M is the midpoint of PB, so M is marked as the midpoint of PB here. So I would put a half here to indicate that it is the midpoint of PB. So we've used that information as well. Show that NMC is a straight line. So the line that they're asking us to show that it's a straight line is N to M to C. Okay, so something like that. The diagram is not an accurate diagram, so we're not going to have the line smoothly going through it, but we know what we need to prove. Okay, so there is a standard way to start a proof where it says that NMC is a straight line, or 3 points form a straight line. So the vector that you must calculate is the vector NM first, and then NC. Okay, I'm going to get started with it, and I'll show you later how we would do any proof regardless of what the 3 points are, okay, for a straight line. So we're going to do NM first, and always the part A links to part B somehow. So here, we remember we calculated the vector PB before. So the path that we're going to take to reach M is the quickest path, so N to P, and then P to M. Okay, the vector that we previously calculated was PB, so we're going in that direction. So N to M is going to be vector NP plus PM. Okay, that's going to be NP is B and PM is half of PB. Okay, and that's the vector we previously calculated. So minus 3B plus A. You need to expand that, collect the like term, so B minus 3 over 2B plus a half A. That's going to be, so 1, which is 2 over 2, minus 3 over 2. You can think of it like that. That's going to be minus a half B, 1 minus 1 and a half, so it's minus a half B plus a half A. Okay, that's the first one. The next one that we need to calculate is vector NC. Now, vector NC is going to be taken from N to A and then A to C. Okay, so N to A, again, we're going in the opposite direction, so it's minus 2B, and then A to B is going to be 2A. Okay, so what we're doing here is we have to factorize these terms out. Okay, so here I can take a half out. If I take a half out, I'm going to end up with minus b plus a here. Okay, and what you're looking for is the same vector when you factorize the term out of this. So we can take a 2 out of this, and we'll end up with minus b plus a. So what's happened here is They are both multiples of minus b plus a, nm and nc. Okay, which means they're both parallel vectors. And we also realize that we have a common point n for these two vectors. If two lines are parallel, okay, and then they have a common point starting over here attaching to those two parallel lines, they must be the same line. Okay, we have a point here, a point here, a point here. They must be on the same line. Now, this proof is not done yet. You have to write a statement in the end. You're going to say that nm and nc are multiples of minus b plus a. Okay, they're both multiples of this vector, therefore they are parallel. Okay, they both share a common point of n, therefore nmc is a straight line. Okay, straight line. Now this statement I've written in two parts, so for you to see that, the first part is that they show that they are parallel. The second part, you show that they both have common point. Therefore, it's a straight line. You must write it. It's a C1 mark in the mark scheme. It's a communication mark. In order to get that mark, you must write it. After all that hard work, don't lose that mark. Okay. The last thing I want to tell you is how do we show it for any points. So if you have a vector where you have 3 points here, so you have a point A, B, C, A, B, C, and you want to show that A, B, C are parallel, then you always do the vector A, B first, and then you do A, C. Okay, and you will have a multiple. When you factorize those two vectors out, you have a nice multiple, so you know that you've done that right. Okay, and then you just say that A is a common point. This is a standard way to prove these questions. Okay, thank you for watching.